Welcome to the Deep Dive. Today, we're really digging into VMware's Telco Cloud NFV. That's Network Functions Virtualization.
That's right. And we're using some interesting sources today, practice questions actually, from the 5V0-37.22 certification exam.
Yeah, exactly. So each question and its explanation is like a little nugget of insight. Our mission, to give you a clear handle on the core parts of VMware's Telco Cloud, why it's important, but without drowning you in tech speak.
Okay, sounds good. It's a big shift, this whole NFV thing. Traditionally, telcos used all this specialized hardware for everything.
Routers, firewalls, all that physical kit.
Exactly. And NFV, it's about running those same network functions, but as software on more standard IT infrastructure. So these questions should give us a good window into how VMware specifically enables that.
Definitely. So first things first, the foundation. Question 1 asks, basically, what's the VMware product that acts as the base for deploying and managing these VNFs, the virtual network functions in the Telco Cloud?
And the answer that pops up is VMware Telco Cloud Infrastructure.
Right. So why that platform? What makes it foundational? Is it just vSphere with a different name?
Well, no, not quite. It's more than that. It's actually purpose-built, tailored, you could say, for the pretty intense demands of telecom workloads.
Intense how? Like performance, reliability?
Both. It's engineered to tightly weave together compute, storage, and networking, but optimized specifically for that high throughput and, crucially, the 5 nines or better reliability telcos absolutely need.
Okay.
Think of it like building a race car. You wouldn't start with a standard family car chassis, would you?
No, probably not.
Right. So this specific tailored foundation, it's essential for properly running those VNFs we talked about. For you listening, getting this base layer down is really the first step. Everything else kind of builds on it.
Makes perfect sense. So, okay, we have the foundation. Now, how do we actually build something on it? How are the individual VNFs put together to make a whole service?
Yeah.
Question 2 brings up something called the Network Service Descriptor, the NSD. What's its job?
The NSD. Think of it as the master recipe, or maybe the blueprint for a complete telecom service.
Like a mobile call or streaming video, something like that.
Exactly. Those services aren't usually just one single VNF. They're often composed of several different VNFs working together, maybe a virtual router, a virtual firewall, a load balancer.
Okay.
The NSD is what defines all that. It spells out which VNFs are needed, how they connect to each other, how they should be deployed, and importantly, how they behave operationally, throughout their whole life.
So it's the high-level plan that tells the system, here's the service, here are its parts, and here's how to manage it all.
Precisely. It defines the structure and the behavior of the complete network service.
Got it. So if a VNF is maybe like one app on your phone, the NSD is more like the description in the App Store, saying what the whole experience is, how it installs, what other bits it needs.
Yeah, that's a pretty good analogy, actually. It captures that idea of defining the whole package.
Okay. And that leads nicely into the networking side of things. Question 3 points to NSXT. Its main contribution is apparently software-defined networking and microsegmentation. What does that mean in practice?
Right, NSXT. This is where it gets really transformative, I think. Traditionally, networks meant physical switches, routers, cables, lots of manual configuration.
Yeah, plugging things in.
NSXT virtualizes that network layer. So you can create network segments, firewalls, load balancers, all in software. It's decoupled from the physical hardware underneath.
More flexible then.
Hugely. But then there's microsegmentation. That takes it a step further. Imagine putting a tiny dedicated firewall around each individual VNF.
Okay. Not just at the edge of the network, but right down at the function level.
Exactly. You can create really granular security policies, isolate traffic between VNFs, even if they're on the same virtual network segment. It's a massive security boost. If one VNF gets compromised, microsegmentation can, limit the blast radius, prevent it from spreading easily to others.
That sounds incredibly powerful, both for agility in setting up networks and for locking things down. Okay, so we have the VNFs, we have the network virtualization. But what's actually managing the hardware resources underneath all this? Question 4 asks about the VIM, the Virtual Infrastructure Manager. What's its role?
The VIM. Yeah, this is kind of the unsung hero working behind the scenes. Its job is to manage the fundamental resources that all the VNFs depend on.
Like the actual servers, storage.
Exactly. The physical and virtual compute CPUs, RAM, the storage capacity, the underlying network connectivity. The VIM allocates these resources when a VNF needs to be spun up, and it makes sure those resources stay available and performant.
So you don't interact with it directly maybe, but it's essential.
Absolutely critical. It's like the power grid or the water mains for your house. You don't really see them, you just expect them to work. But nothing functions without them. The VIM is that for the Telco Cloud infrastructure.
Right, the essential plumbing. Okay, now question 5 moves us towards efficiency, automation. It asks about Telco Cloud Automation, or TCA. What's its main function?
TCA. Yeah, this is all about speed and, well, reducing manual effort. Its core purpose is automating the life cycle of network functions, both the traditional VNFs and also the newer cloud-native network functions, CNFs.
The whole life cycle, what does that include?
Pretty much everything, from the initial deployment, the configuration, scaling, adding more resources if demand spikes or scaling back down, and even handling the eventual retirement or decommissioning of those functions.
Wow, okay.
For the telco providers, this automation is huge. It means much faster service delivery. Think weeks or months potentially shrinking down to days, maybe even hours for some things, fewer areas for manual steps too, and just generally being able to react faster to market changes.
So it frees people up from repetitive tasks to focus on, I don't know, designing new services.
That's definitely a major benefit, yeah. Innovation instead of just configuration.
Makes sense. Which brings us to question 6. Why are telcos even doing this? What are the big picture benefits driving NFV adoption?
Well, the practice question highlights 2 key ones: greater service agility and faster deployment. And that really ties back to what we just discussed with TCA.
Right.
Think about the old way. Launching a new service, it could take months. Planning, ordering specific hardware appliances, shipping, installation, configuration. It was a long process.
Very hardware-centric.
Exactly. With NFV, because it's software running on more general-purpose infrastructure, you can spin up, test, and deploy new services much, much faster. That agility is crucial today. Speed to market is everything in such a competitive space.
Absolutely. Being first with a new offering or being able to tweak existing ones quickly, that's got to be a massive advantage. Okay, moving on. How do you keep an eye on all this complex virtual stuff? Question 7 asks about monitoring health, performance, availability. The answer given is vRealize Operations. What does that tool do?
vRealize Operations, or VRUps as it's often called. It's essentially the central monitoring and management dashboard for the whole Telco Cloud environment.
The whole thing, VNFs and the infrastructure.
Yep. It looks at the health, the performance, the capacity usage, not just of the individual VNFs, but also the underlying Telco Cloud infrastructure components, the compute, storage, network managed by the VIM. It gives you that holistic view.
And why is that so important?
Well, for ensuring service reliability, right? If a customer service is slow, you need to know why. Is it the VNF itself? Or is the underlying storage struggling? VRUps helps pinpoint those issues. And it's not just reactive, it does predictive analytics too, trying to spot potential problems before they impact service.
Proactive monitoring.
Okay.
That's vital for keeping customers happy. Now let's talk security again, but from an access perspective. Question 8 is about controlling who can do what. It asks about the mechanism for ensuring users only access authorized resources. The answer: role-based access control, RBAC. Why is RBAC so critical here?
RBAC is fundamental in any complex shared environment, and Telco Cloud is definitely that. You often have different teams, network ops, security ops, service designers, maybe even different tenants or customers using the same platform.
Right, you can't have everyone with admin access to everything.
Exactly. That would be chaos and incredibly insecure. RBAC lets you define specific roles like VNF deployer or security policy admin and assign very specific permissions to each role. This role can deploy VNFs, but can't change firewall rules. This role can monitor performance that can't delete anything.
So least privilege access.
Precisely. It ensures people only have the permissions they absolutely need to do their jobs. It prevents accidental mistakes, limits the damage if an account gets compromised, and it's essential for auditing and compliance, too. You need to know who did what.
Makes total sense for operational control and security. Okay, question 9 zooms back into network security specifics. It asks about the component used to enforce rules for traffic between VNFs. The distributed firewall comes up. How is this different from a traditional firewall?
Right. The distributed firewall, which is often part of NSXT that we talked about earlier, the key word is distributed. Instead of having one big firewall at the edge of your network, or maybe a few internal ones, the distributed firewall embeds firewalling capability directly into the hypervisor, the software layer running the VMs. So security enforcement happens right at the virtual network interface of each and every VNF.
So it's much closer to the things it's protecting.
Exactly. It allows for those microsegmentation policies we discussed. You can enforce rules about which VNFs are allowed to talk to which other VNFs on which ports, regardless of where they sit on the network. It's not about just north-south traffic coming in and out, but also the east-west traffic moving between components within the data center.
So much more granular control, stopping threats from moving sideways if they get inside.
That's the core idea. It significantly strengthens the security posture inside the telco cloud.
Okay, fascinating. All right, our last question, number 10. It looks at the bigger picture of managing everything, the orchestration. It asks about the element in the NFV M&O framework that's management and orchestration, responsible for orchestrating network services across the entire infrastructure. The answer is the NFVO, Network Function Virtualization Orchestrator. Big title. What does it do?
The NFVO, yeah, think of it as the master conductor of the whole telco cloud orchestra. It sits above the VIM and the individual managers for VNFs.
Okay, so a higher level view.
Right. Its job is to manage the end-to-end life cycle of network services. Remember the NSD, the blueprint. The NFVO takes that blueprint and makes it real.
Also.
It coordinates everything needed for that service. It talks to the VIM to get resources. It tells the VNF managers to deploy and configure the specific VNFs. It sets up the connections between them based on the NSD. It manages the deployment, configuration, scaling, and even healing or decommissioning of these complex multi-part services.
So while the VIM manages resources, the NFVO manages the services built using those resources.
Mm-hmm. You've got it. It's the brain overseeing the deployment and ongoing management of those complete, often intricate network services that the telco offers to its customers.
So here's something to think about as we wrap up. As these telecom networks become increasingly defined by software, managed by automation, secured in these granular ways, what truly new kinds of services might become possible? What innovations could emerge that just weren't feasible when everything was tied to physical boxes?
Yeah, moving beyond just replicating old services and software, what totally new things can be built?
Exactly. Something for you to ponder. Thanks for joining us for this deep dive.